know it's you.
All right, let's go ahead and at least do part of this lab, because I know y'all are just dying to do it. Dying.
Literally.
All right, let's go into the HPP file. Oh, hey, look, I already wrote a pair. Do you want to use our own pairs?
Sure.
Or do you want to use the STL pairs?
STL.
STL.
You want to do the STL pairs? All right.
Easy.
Maybe. All right. Okay. One thing I haven't really talked about, there's an instance where you could do a .get and you don't find it. And I told you to return the empty example of what it is. Over here, I'm telling you how to do that. Create a variable of type v calling m invalid, has no default constructors. When you can't find the element, return m invalid. All right? Normally you return like -1 or 0, but this is just a way to give back something that's invalid. That's all. All right. But now we're going to go back to hash table with open addressing, and I just realized I didn't even look at the PDF. Y'all already know what it is? All right. Bless you. Let's see. Take an integer. You need to implement load factor, insert, remove, and get. If the value is not found in the hash table, return a default constructor. Warning, big warning. Your load factor function must work properly to pass any test cases. If your load factor function does not work, you are going to fail every single test case. Just FYI, throw that out there.
Nice.
Yeah, thanks. I worked hard. All right, we're apparently going to ignore this pair and write it ourselves. You still have, there, got me doing it now. Hash table can pass the size, and I'm passing you the load factor as a constant float, so you'll have those two values. Naturally, a destructor. Insert a key with the value. Be able to print it. This is for your own edification or your own testing. I'm not going to test your print function. Be able to remove something based on the key, and of course be able to get something. And then lastly, return the current load factor for the hash table, not the one passed in. It must be work properly for your test cases. And let me just see something real quick. All right, and we're good. Okay. So let's go ahead and at least start with our type, data type, hashtable.hpp. All right, so I have an invalid. We're doing hash tables with open addressing. So what is our data structure? The vector could start. Vector of something, we'll go ahead and call it mtable for now.
Called me David.
What was that?
No. I was filling Jonah in how you called me David. So. It's okay.
Did I just call you David again?
No.
Okay.
Jay called me David. So.
It's all right, Matt.
Good.
Is that your middle name or?
No, David.
No, David. Why do I keep calling you David?
Just a pretty straightforward name. Pretty boring.
Pretty boring name.
Not David.
Short for Matthew?
No.
They just called you Matt? And
Yeah,
didn't,
just Matt.
they didn't want to give you any extra letters?
I respect that. Yeah.
I do.
It's easy. No, it's actually Matt.
Oh, now my respect just dropped.
Yeah.
Yep.
But
Now it dropped because you
My
lied
name's
to
actually
me.
David.
You just lied to me. Yeah.
It's not.
No, but my real name is David. Short for Matt. I'm so.
What would you like to be called?
Preferably Matt, but you
Okay.
can call me David if you want.
All right, David. All right, or Matt, whatever. What is it a vector of? What would you? Pairs. Okay. Okay. Now, when we create this M table, are we going to automatically be creating all these pairs? Yes. Does that make sense? Also, what is this a pair of?
key and value.
Yeah, so we need to do this. It'd be automatically creating all those key value pairs.
Now, do we have to call it the way that, like, you did it?
STD does not name a template type. What? Did I not? Oh, I didn't include vector. Whew. Works like a champ. All right. Okay. Do we want to be automatically creating each of these pairs?
Do we want to?
Yes.
No.
No. How can we get around that? We can use a
Crickets. Pre-constructed.
constructor. Yeah, I totally made that term up. It's not the. I don't remember what it is. I think it's like initializer list or something. I can't remember what the term
Let's
was.
call it the pre-constructor.
The pre-constructor constructor. Yeah, the pre-structor. The pre-structure.
That's not the answer.
No.
I thought it was for a second until I realized it got quiet again, and I was like, oh, that's not what he was looking for.
I really thought y'all were just joking too.
Oh, well, you know, it was fine.
Yeah. No, I was.
It was just a joke.
I was fun. I was laughing. Yeah. Okay, well, we'll let that be for a moment. What else do we need to store in here?
Key.
The key. In the hash table. What are
You're not
we?
gonna, I was going to say, you're not going to need size, are you?
So we do need to store the size. That's correct. Luckily, the size will be stored inside a vector for us. So we're good there, right? That is the correct answer, but we got that already.
Okay.
What else are we missing? That comes after size.
Capacity?
It begins with const float.
Load factor.
Load factor. Why do we need to store load factor?
Oh, that's right.
All right. So M lead factor.
Whoa.
You're going crazy today. Tabbles.
First it was all about the tabbles. Now, oh man.
Yeah.
All right.
You missed a lot of good stuff.
And actually, you are correct. We forgot the size
Ha-ha!
because we need to start that at 0. But we do. Let's use the initializer list to pass it in here, so that the table will automatically be initialized with the right size. Then we'll have our own internal size start at 0, and then our load factor be copied over as well. All right, great. We're doing wonderfully. All right.
Should those sizes be M size or no?
That size up here is the size that's being passed in.
Oh, okay.
We don't have access to M size yet. Plus, M size is not going to be this size. This might be capacity, might be a better word. But I just called it size for now. All right. Which function would you like me to implement?
Yeah, that would be awesome.
But we're not doing remove.
But then he'd have to give us insert and
Yeah, good try. Actually, you know what we really need to do first? Load factor.
load factor, and then we can do insert, and then we can do
Yep.
This is a good plan.
Why is load factor returning an integer? Who wrote this code?
I don't know. I would assume you did.
Yeah, I would assume you did too.
We're going to change this to a float? Man, who did this? That's terrible. We're changing this to a float. That doesn't even make sense.
I think we cast it too.
What? I'm so glad I'm doing this one in class. I don't even know where this code came from now.
So then we should go ahead and do remove. Just to be safe.
Just to be
Just
safe.
on the safe side.
All right. How do we calculate the load factor?
Where are you? Hey, it's
Happy
Monday.
day this
It's
morning.
Monday.
It's not a good day for
It
me.
is okay.
Load factor.
Did you have your tea?
Not too much of it.
There you go.
I also have not been practicing the Japanese, which makes me sad. Sorry. That's probably what's causing this.
Yeah.
All right. How do we calculate the load factor? How do we calculate the percent full? That's what load factor really is.
I guess you can just kind of iterate through and figure it out.
We could do that. All right.
Divide
These are
it-
the variables we've already
Divided by
stored.
size.
Oh, divide by
Yeah.
size. Okay, so
See if it returns the load.
divide by. Okay. All right. So we're gonna.
I see what I want to say.
Yeah, but you can't get it out.
Current load factor. All right. We'll have that start at 0.0. All right. How do we? That's just current load factor. What's a?
So
Load factor that's passes in a decimal.
Yeah. The okay. Maybe I need to get better names.
It passes in a value between 0 and 1 that represents the percentage of how much load is under.
Yeah. Let's. It is called load factor, so I need to stick with that name. Let's do this. Let's call it percent full. How about that? That make more sense?
Sounds nice.
I think that makes more sense.
Well done.
Because the idea is your percent full has to be, we're going to say, strictly less than your load factor at all times. Okay? I'm going to call this, I'm just going to call it, I want to call it P full, but hopefully that won't. All right. All right, so, bless you.
Bless you.
So start to 0. Is it really that? No.
no.
All right, how do we figure this one out?
So it'd be like your table size
The tables.
divided by how many keys you have.
Which would be in size.
Yeah.
But that's backwards.
So M size divided by.
Yeah. Now we need to make sure they get converted to a float. So by doing this, ensures. Let me try again. Is converted to a float, and then P full divide equals by in table dot size, right? So that's the number of elements divided by how many elements we can store. That should give you the percent full. Right. And it's very common to actually store it as a decimal between 0 and 1. So we're going to leave it that way. That's how I want it. Because that's how I'm going to write the test cases for this one. Since apparently they don't currently exist. All right. We should start testing, right?
Yes.
Test, we'll call it load factor test. I'm just going to call it the LF test because that's way too many letters. What?
Keep it simple.
Keep it simple. All right. Hey, look at this. 100 elements, load factor 0.8. Oh, that's great. Okay. So TS assert equals. We want to do ht.load percent full. And that should be 0.0, right? Right there. Okay. Make IF test. LF test. We're good. Okay.
Yay.
All right. Well, that wasn't too bad a test because too much of a test because we can really only do one thing right now, which is fine because now at least we believe that's working well. Let's go ahead and put in insert. I don't know why I did that. Let's do that. Wait, doesn't insert return something? Yeah, it returns a Boolean. This is just not a good day for me. Okay. So how to insert? Quick, tell me what I should do first. Hmm?
Pass.
Have we written something before?
Yes.
Should I copy it? Yes, we should definitely copy and paste. Don't reinvent the wheel, guys. You will be sad. See, watch me. I'm going. Watch me not reinvent the wheel. Put that right in there. It doesn't work yet, but I'm okay with that. And we'll go ahead and take this as well, and we'll put it at the end. Go and close that. All right. So we copied over the old hash codes. We have this capacity, the size, we size it down, and then, well, this is the part that's not correct, right? So let's, this part is probably not good, so let's go ahead and see if it still compiles like that. Not quite, because pair to insert, we need to actually call the std pair of key value to insert, and now we have dot first is the key, and dot second is the value, right? Well, that's part of how pair works. So we're going to recompile. We're good. All right. Okay. How do we? Ooh, how do we add a pair to hash table with open address? Modulus. We've already done that with index, right? Right there.
Oh, yeah.
To make sure that the place you're putting is empty.
Okay. Make sure the place we are putting it is empty. All right, then what do we do?
If it's empty, put it in there.
All right. So really, whatever you begin a sentence with, make sure the place we are putting it is empty. What you're really trying to do, what you really meant to say, Jonah, is find an empty place to put the pair.
Yeah, there.
Yeah, right?
Basically.
That's what you meant to say.
Yeah.
That's
got
what
it.
you really said. All right. It's in there. Okay. Okay. How do we do that?
Are we doing a linear one, right?
Unless you'd like to do something else.
Linear is probably the easiest to code.
Yeah.
Okay, let's look at that.
Okay. Definitely the easiest to code. Although in reality, you're just changing a couple of lines of code to do everything else, but linear is going to be a lot easier to think about.
So you probably want to start at the index.
Okay.
Or, you know, like where your index.
All right. So we have int table sub index. How do we find out if it's empty or not?
If that is empty function.
Well, we're storing a pair there, right? So we're already storing actual values. So we don't want to store just a pair there. What do we really want to store? An object, which means we need to store a, yeah. Oh, so let's change this up. Now it's storing a pointer to pairs. Oh boy. Still compiles. All right, good.
Okay.
All right. This also means we need to do this. All right. Okay. Let's see if that compiles. Notice all it's doing is now making it a pointer, so when we add it, we just put in the pointer. But even more so, when we create this table, what do we actually need to do at the very beginning? Or maybe what do we need to do here? Either case. How do we know if something's empty, or if it's empty?
It's pointing to null.
To null. Since this is C++, when you automatically create your vectors of elements, are they initialized to null?
And undefined.
Undefined. So what do we need to do first before we call insert?
Initialized to null.
Yes.
Was this the answer to what you were asking earlier?
Maybe.
So we're-
Yes. Yes. So equals null. And let's see if that compiles. Yay. All right. Now. So now we have mtable sub index. We're asking if it equals null. So if it is null, we can just put it there, right?
Yeah.
All right. So and that's not hard. So the real question is, what do we do if it's not null?
Find another spot.
Yeah, we need to keep going until we either.
How do we keep going?
Huh?
How do we keep going?
You gotta iterate down.
All right. So index plus plus. Right. Okay.
Huh? Yeah. Oh, yeah.
Okay.
I was gonna say do a while loop, but
There you go. I'm coding it this way just to show you how this is done. Start with an if. If it evolves to a while, that's perfectly fine. All right. Yeah. So start index, try and find something that's not null. Anything else we need to do in this while loop?
yeah, because if you go out of bounds,
There we
you have to
go.
go back to the beginning, right?
So if index greater than or equal to,
Size.
yeah, m table dot capacity. All right. All right. Now index is pointing to an empty location.
Could that get stuck in an infinite
Yeah, that's
loop?
what I was thinking too.
That is a great question.
There's no space?
Yeah. there's no
Yeah.
space. Would you have to call it like load factor? or Something? Figure out what the load.
Y'all are doing great. Let's answer this question real quick. Let's finish this out. If we have an index, it's empty, what do we need to do?
Slap it in there.
Yeah, just put it.
Yeah, mtable sub index equals to insert return true. Okay, great. Now, your question is, could this while loop go into an infinite loop? Currently, yes. How do we stop that from happening?
Load factor.
Load factor. All right. So, what do we need to do?
Make sure load factor is less than the specified load factor.
All right. How do we get our current load factor?
Line the function.
Yeah.
Which one?
Call the function.
There you go. You're doing great. Float full equals percent full. All right. So if p full
Is greater than 0.8.
greater than load factor, right? And actually, if it's greater than or equal to load factor, double capacity.
I think, didn't we change the name of the load factor?
No, we changed the name of the function that calculates the current load
Oh.
factor. I'm keeping the old term load factor because that's what all the literature calls it. I would call it, in my opinion, maximum load factor. Maximum load factor, because I think that hits at home what's going on. But everyone just calls it load factor, so I'm going to keep it with that. I'm going to call this one percent full. Now, if it's greater than or equal to load factor, double the capacity. Now, Is this the right location for this code, or should it be somewhere else? Okay, that's...
Probably should be right in the beginning.
So if you have no items in it, you add something to it, then you check the load factor. Why would you check the load factor beforehand?
Because if you check the load factor before you add anything, it's not going to do anything, right?
Right, you probably want to do this afterwards. Maybe down here. Alright, I'm going to go ahead and give you a private function. We'll call it double capacity. I'm going to put it right down here, and I am not going to implement it. My sentences are ending with semicolons. Alright, so now I can uncomment this. We'll go over to number 2. Hash table, double capacity, doesn't that match any of it? Probably because I didn't put the word void in front of it. There we go. Compiles. Alright, perfect. So if it's greater than the load factor, I want you to double the capacity. I'm telling you all to do this. Make sure you do double it. Because if you don't, then your load factor, when it asks for your load factor later, or your percent full, you're not going to give it the correct amount. For instance, if you increase it by 50% instead of doubling it, when I expect you to increase your capacity, it's not going to be to the correct number. So make sure you double it. All right? Everyone okay with that? Just make sure you actually double it. Don't increase it by like 10%. Double it.
So our double capacity will also then call like insert again.
Yes. Oh, it's going to be great. And I'm going to make your life...
You have to everything at the end to do.
So this can get a little tricky because of the way we've been doing this hash table. To make everyone's life easier, I know you're going to be sad, but trust me, you're going to like this. I'm going to make this a pointer too. That way you can just, inside of double capacity, create a new hash table, do everything to it, and then at the very end, copy the pointer over. All right, guys? All right.
Thank you.
That's, yeah, if you didn't know to do that, you were going to be staring at this code for a long time. Although now we need to fix a couple things. Now mtable needs to be equal to, oh no,
No, you're losing.
I'm losing power.
See your work to avoid losing your data. Shut down the system.
wow.
Hurry, it's dying.
It's dying, we're almost dead. Oh, that's so funny.
That's when you start like Inception, is it?
There we go. All right.
Oh, your battery's
All right, last time I did this, I accidentally clicked shut down system, so, okay, good, I didn't that time. New. Oh, that was funny. What was this again? STD vector of the pairs, which were of key, comma, value of size. Perfect. And now, everywhere we have the thing dot, we need to replace it with arrow. All right. Something is sticking. And then, oh.
Oh, it's sticking.
Then we gotta do this. Yeah. Whoops. And we gotta do this. Yeah. Yeah. It's like that. It really is. Okay. Let me make sure that compiles. Didn't think so. Cannot convert int to int star. Cool.
Also, it says your double capacity doesn't look good.
Hang on, one thing at a time. Hold on. Oh, because this needs to be a pointer. Perfect. Okay, whoa. error, no operation null. So we gotta do this as well. Wow, this is frustrating. Oh, then it worked. Okay, good. Oh boy, this is gonna be fun to code.
You know, this went from it's gonna be okay to uh-oh.
Oh my!
Which doesn't make any sense because we actually did something good.
Yep. Oh well. That's how it goes sometimes in life.
That is, yep.
How the cookie crumbles. Alright. I feel like we're missing something. Oh no, I told you how to help you with capacity, percent full, and I'm going to let y'all do remove, because I know
No, capacity and remove? Oh my gosh.
It was
I-
worth a shot. Guys. I was trying to get it to remove.
Alright.
I feel like double capacity would probably be just.
Well, I mean, if we changed it to pointers, remove,
Might not be too bad, yeah.
Yeah, remove's gonna be better now that you have pointers.
yeah.
Yeah, everyone hear that? You all just agreed with me. I said it's gonna be better with pointers, and everyone just said yes.
Well, better. It does not mean it's not hard.
All right, just want to make sure that was clear. Any other questions before I commit this code and let y'all loose? We'll have an hour and 5 minutes for lab time. Make sure you get your project 3s in. Shouldn't be too bad. Shouldn't, huh? No questions?